Hello, Pre-Calc. Today we're going to use polar curves, take a look at their graphs, and specifically maximum and minimum values and zeros. We're trying to come up with easy ways to graph these polar curves without having to just create an entirely huge table of values and plug and chug. So our similarity tests that we used last week are going to come into play. We're not going to apply them today, but that is one tool to help us look at the graphs. And today we're going to be looking at the tool of maximum, minimum, R values, and zeros. So grab your notebook or your printout of the notes. We're going to look at two examples together, and then you're going to get to finish the examples for homework. So let's take a look at example 1 here. R equals 2 plus 4 cosine theta. Now what we're going to do is we're going to think about this cosine function in here. And if you think about the cosine, I'm going to draw myself a nice little unit circle just for a visual reference. The cosine has a maximum and a minimum value. It bounces between -1 and 1. Here's our maximum value, cosine of 1, and here's where our minimum value of -1 are. And those are going to provide those extreme R values for us. And so we can think, well, the cosine has a maximum when theta is 0. And I'm going to take one trip around that unit circle. It also is back at that maximum of 2 pi. Now, some people don't include that 2 pi because they just want to go 0 to less than 2 pi. I like to think about that. It closes my trip around the unit circle. So that's where the maximum values are. I'm going to just draw a line across here, and this bottom section I'm going to use for the minimum value. Where is the cosine at a minimum? Well, that's going to be over here at pi, just at one spot. And so these three theta values are going to provide the extreme R values, the maximum and the minimum R values. And so when theta is 0 or 2 pi, that's the maximum of cosine, that's at 1. That means our R, according to our equation here, would be 2 plus 4 times 1. That cosine value would have the maximum. Well, that means R is 6. So that's an extreme R value. That's the maximum R will ever be. R will never be larger than 6, and it will occur at 2 spots, at 0 and 2 pi. So I could write 2 ordered pairs here. 6, remember, it goes R comma theta. There's an R theta, 6 comma 0, and 6 comma 2 pi. So those are two extreme values that I know on this polar curve. I could plot them. They would be right here at 0, theta is 0, R is 6, and that also happens to be the overlapping point at 2 pi as well. And again, sometimes you'll get that redundancy. It will close our curve as we graph it. Now, here at theta equals pi, that's where the cosine was -1. This is going to be our minimum R value. And so R would equal 2 plus 4. The minimum cosine value is -1. So that'd be 2 minus 4 is -2. That's an extreme R value as well. A nice one to find. And so our theta would be the point -2 comma pi. And I can graph that as well at pi radians. I'm going to R value of -2. Remember, that means backwards. So here I am at 2. So that provides a couple of points on my curve fairly easily. Those are the extreme values, the maximum, and I refer to them as the minimum. This worksheet doesn't talk about a minimum value, but I like to think about the max and min of that cosine function. We can also find zeros. Take your equation and set it equal to 0. Now we have a nice trig equation that we can solve. I'll move that -2 over, and I like the cosines on the left-hand side. So 4 cosine theta would equal -2. Divide both sides by 4. And we have cosine of theta is -1/2. Now think back to the unit circle again. Where is the cosine or the x-coordinate -1/2? Well, that would be over here at 2 pi over 3. It'd also be down here at, that's 2 pi over 3, 3 pi over 3, 4 pi over 3. And we have 2 more points. The r value is 0 when theta is 2 pi over 3, and it is also 0 at 4 pi over 3. Now these are coming through here, and since it's 0 away from the that origin there, it just sits there. It doesn't matter the angle of rotation. They both hit back at the same spot. But as we go to graph them, we're going to see that it hits that spot at a couple of different times as theta progresses around the unit circle. So to find the rest of this curve, we could put into play our similarity tests, and that would be helpful too, to know, are we dealing with, symmetry across pi over 2, or are we dealing with it across the polar axis or pole symmetry? But we're going to hold off on that. I'd like you to grab your calculator. And we're going to take a look here. I've got my TA84. And if I were to graph this polar function, you can see I pressed y equals here. In no way am I equipped right now to put in thetas and r's. And so what you need to do is you need to change the mode. So if you press the mode button, and then here, mine's right here on the function, I really want to be not in par, that's parametric. We'll get to that in a couple of days. We want to be over here on polar. And so if I switch this to polar mode, when I press the y equals button, it suddenly becomes an r equals button. Really handy. And you'll notice the same features on Zoom, and you can look at a normal standard graph. And Window, however, is a little bit different. Window has a starting value for theta and a maximum value for theta. And notice mine is going from 0 to 2 pi. That is the default if you choose the standard window. And then it still has x minimums and y mins and maxes. And so you can decide your left to right, your horizontal and vertical axes there. So if I do want to keep this in standard. So if yours doesn't look the same, press zoom and then 6. And then you can go back to window and you should have this standard window. We're going to adjust that a little in our next example, but we'll take it one piece at a time. Go ahead and press the y equals there. Now it's r equals. Now, just by changing that mode, it changed this button right here. We're no longer going to be using x as the variable, where when you press that, it will give you a theta instead of the x. It's really nice. So let's put in this graph, r equals 2 plus cosine of theta. And let's just take a look. I missed the 4, didn't I? get a 4 in there. 2 plus 4 cosine of theta. Let's take a look at that graph, and I should expect to see these 3 points on it. It's a little swirly around, but you can see my 3 points that I had from my extremes and my zeros. Now, this is a little bit smushed because the horizontal axis is a little extended than the vertical. So to square that up, go ahead and press zoom. And if you press number 5, Z square, it will make all of those tick marks visually the same. Okay. Now, do you notice what happened as that graph? It came up this direction and came through and swirled around and back. And so if we look at what's happening here, we start at with theta 0. The next point here for theta would be 2 pi over 3. We're at 0. So when we come to 2 pi over 3 in our angle rotation, we're going to be back to 0. So it looks something like that, back to 0. And then after 2 pi over 3 would be pi. At pi, we're at -2. All of these values here from 0 to pi have -r values, and so they're going backwards. So it goes backwards there, and it swirls through and back to 0. Mine's not very smooth there. Back to 0 at 4 pi over 3. This angle right here is 0, and then comes back through, and there should be some symmetry there. I did not do that very well at all. There we go. There's our graph. And so I would like for you to find the extremes, to plot them. Then go ahead and use your calculator to help you fill in those pieces. But think about where it's starting over here at 0 and the path that it's taking. It's a very different way to graph than our normal rectangular coordinates in X and Y. All right, let's try the next one. Here we've got r equals 3 sine of 2 theta. Now, the very first thing I want you to notice here is that we have a 2 theta, not just theta. So normally we're going from 0 to 2 pi, right? Theta seen between 0 and 2 pi. But now it's 2 theta. Remember this from solving equations? If it was a 2 theta, we need to double each of these endpoints. So as we look for maximum or extreme values in zeros, we actually are considering the domain 0 to 4 pi because of that 2 theta in there. So that's an important piece that you have to keep in mind. All right, so let's think about our extreme values. We're dealing with the sine function here. So the sine has a maximum of 1 at pi over 2. So this would be when 2 theta is pi over 2, but also when 2 theta, we have to go all the way to 4 pi. So here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Since we have to go around that unit circle twice. That's what that 2 is telling us. Go around twice. So now we're going to have those extremes. If I just solve for theta, divide both sides by 2, this becomes pi over 4, and this becomes 5 pi over 4. That is where we'll have the extreme value of 1. That means the r value is 3 times 1, because that sine of 2 theta was at its maximum. So r is 3. So we have 2 pairs here. We've got 3 comma pi over 4 and 3 at 5 pi over 4. All right, those are our maximums. Well, when is the sine function at a minimum? That's up here at 3 pi over 2. So 2 theta is 3 pi over 2. But then if you go one more time around the unit circle, so 3, 4, 5, 6, 7 pi over 2. So that would be at 3 pi over 4. Theta is 3 pi over 4 and 7 pi over 4. What is the r value at those 2 angle measurements? Well, that we go back to our equation 3 times. Here's the sine function. At the negative was -1, so r would be -3. So we also need to consider the ordered pair. R is -3 at 3 pi over 4 and -3 at 7 pi over 4. All right, we can plot those. At pi over 4, we're at 3. Notice the scaling here, 1, 2, 3. So pi over 4, we're at 3 at 5 pi over 4. 1 pi over 4, 2, 3, 4, 5 pi over 4. We're also at 3. At 3 pi over 4, we're at -3. So you have to go backwards. Be over there. And at 7 pi over 4, here's 7 pi over 4, we're at -3, so you have to go backwards here. Which you're probably thinking, why don't we just have 3 at 7 pi over 4 and 3 at 3 pi over 4 instead of doing the negatives? And those come into play just in the direction and how this traces out. And we'll see that when we get to our calculator. So right now we've got these nice 4 extremes. Let's see when we come back to 0. I'm going to take and set that equation equal to 0. Divide both sides by 3. So 0 equals sine of 2 theta. Again, thinking of the unit circle, when does the sine equal 0? That occurs at 0 and pi. But I do need to make it all the way around to 4 pi, so I've got more than that. So I'm looking for this argument. When is the whole argument going to be at those spots? It will be at 0. Pi also has a sine of 0, and back to 2 pi. And I want to keep going to 4 pi, and 3 pi. And then 4 pi takes me all the way back home. Now, 2 theta is equal to each of these, so I'm just going to divide each one by 2. So 0 divided by 2, pi divided by 2, 2 pi divided by 2 is pi, 3 pi divided by 2, and 4 pi divided by 2 is 2 pi. At all of these angle measures, we are back to the pole right here at that center point. So we start out there. When theta is 0, we are 0 apart. But then we go all the way out to 3 at pi over 4. So this is going all the way out here to 3 at pi over 4. But then by the time we're back to pi over 2, we're back to 0. We're back to that origin. Then at the next piece, we head to 3 pi over 4, but that's at -3. So you don't want to go out this direction. It's going a negative direction. So it's going to come here because the r values are negative. And then after 3 pi over 4, we are back to pi, which is back to 0. So after pi would be 5 pi over 4. So we're actually headed down into quadrant 3. And after 5 pi over 4 is 3 pi over 2, back to 0. And then we are to 7 pi over 4, but the r value is negative, so it's not going to be over here in quadrant 4. It's going to send it to quadrant 2. Out back here, and then back to 0 at 2 pi. And we have this lovely petaled flower. Grab your calculator and let's see if we can make that happen. So I'm going to delete this here, but the first thing I'm going to do is go to my window. Notice I need to go from 0 to 4 pi here, but my theta is only going to 2 pi. So I'm going to go down here and just go 4 pi. Now, as we found in some of the tables before, sometimes we have some repetition, and if we have some symmetry, there might be also some repetition, and we might find that here as well. But I like to put that out there just in case. And in some of your homework examples, you're going to need to make sure to change that, or else you're going to be missing pieces of the graph. Does make it interesting. Hit the y equals, or in this case, the r equals, and we're going to put in 3 sine of 2 theta. All right, now watch the direction it graphs and see if we actually did it correctly. If you hit the enter button while it's graphing, it will put it in pause mode. So I might do that here if you're wondering what I'm doing. So here we go. Oh, do you see how it went out that direction? Notice here my little, I don't know if you can tell on the video, but it's toggling little pixels. And so it's in pause mode. But we did quadrant 1 first, and now it's graphing in quadrant 4. And then it moved to quadrant 3. And there we go. Now, if you want to take a better look at that, you could change your x-min and x-max. Maybe I'll do -5 to 5 in either direction. And it's, let's take a look here. There we go. And it's not quite as symmetric because when I changed them, I could square it up now. And you can see the symmetry and the order in which it is graphing. So I want you to be finding the maximum and minimum values, those extreme R values based off of that trig function. And then the zeros, plot those, see if you can predict what the graph will look like just with those pieces, then use your calculator to help you. I've got a couple of hints on the homework, just things to be thinking of. Let's look at that next page. Helpful hints here on 4 cosine of 3 theta. If you have 3 theta, normally we go between 0 and 2 pi. So if you make that 3 theta, this one better go between 0 and 3 times as much. 6 pi, there are quite a few spots to look for there. There are some repetitions, so that's okay. All right, other helpful hints down here on example 5. You also have a 2 theta, so make sure that you're going between 0 and 4 pi, twice as much. You also have an r squared. When you go to put this into the calculator, you are going to need to take the square root of both sides. You can't put it in an r squared. And so you're going to need to take the square root of both sides, which makes this have a plus or minus. This is just for the graphing piece. that means you're actually going to have to split that between two r's. Like R1 would be your positive square root of 36 cosine of 2 theta. And then go to the next line and put R2 is negative the square root of 36 cosine 2 theta. This one in particular, make sure you're changing your theta max in that window or else you won't have pieces of it. But I think you'll do okay. If you have other graphing tools to help you like Desmos, that's helpful as well. Explore them. Ask yourself questions about them. They are interesting curves. They have different characteristics. And when we come back, we'll see if we can put more of those characteristics to work. All right. Email any questions.